Hello, everyone. Welcome to my talk today. Let me share my screen and give me a sec. Okay. Okay, so if somehow for some reason you cannot see it, please let me know. But otherwise too, I'm assuming that you can see my screen. So welcome to my talk. I have kind of modified the title a little bit. I've been talking about event streaming, processing, messaging, with Apache Pulsar. And I realized that there's been a lot of kind of confusion perhaps, or like a bit of misunderstanding, particularly if you have not worked with event streaming, event type of programming, asynchronous programming. So I kind of call this a gentle introduction because I'm going to spend a few minutes going through some basic first before getting into a bit more, and then also into Apache Pulsar. So welcome, and here today, my name is Mary Grigleski. I'm a streaming developer advocate at DataStax, and so welcome. Let me move on. And also too, if you are interested in this slide deck, feel free to, now I'm gonna leave this on for like 10 seconds or so. If you want to quickly take a, kind of snapshot of this QR code, it will give you the access to this slide deck. Now, even if you miss it, don't worry about it because I'm going to be sharing this slide deck with the organizers here afterwards as well. And also too, if you kind of like to keep in touch with me, there are also connection info that you can follow me on Twitter and all these things, and even my Discord, that then I can share the slide deck with you too. So, okay, with that, I'm gonna move on. So who is Mary, right? Who am I? I'm a senior developer advocate at a company called DataStax, which is based in California, headquartered, but we have folks working from all over the world too, including, Europe, I think South America, Asia, and also I believe even on the continent of Africa as well. So anyway, so I am there, and if you have worked with or heard of, right, Apache Cassandra, and that's the company is famous for. Because of Apache Cassandra, we have a managed cloud platform called Estra, and right now too, like a year and a half or almost 2 years ago, company decided to also kind of extend into other areas, which then now they decided, okay, is naturally going into event streaming, and of course event-driven, all of these event-driven architecture programming are becoming like so, kind of hot, so to speak, right? But as such, it isn't really new. So let me kind of, I just want to again give you an introduction to DataStax first. And prior to this too, I was with IBM. I was with the Java developer advocacy team for like 3.5 years with Java, and then working on the open source side for WebSphere team too. I'm based in Chicago. I'm also a Java champion. I'm also the leader, the president of the Chicago Java Users Group. And in fact, tonight too, we're gonna have an in-person meetup, but we're going to try to stream it too. And if not, you can always look, watch our videos with really good speakers too from all over the world. So I'm an active, community builder, so to speak. I'm actually, for me, right, I guess sometimes folks, maybe if you're doing advocacy, you might think that, well, we're kind of more like non-technical, but no, I actually was a developer myself for over 25 years. I was with a variety of companies. So for the past 20 years or so, I was doing primarily like Java and open source development and in different, IT shops. So I can understand the environment that perhaps you are in. I mean, things have changed, but I think pretty much too, a lot of things are kind of the same. So here are the links of how you can get a hold of me, right? Twitter, LinkedIn, Twitch. I have a Twitch stream, and also I have my Discord server. This is just to share with you my company kind of bio page too. So these are just all about me in pictorial form, but I already told you about me. Okay, so without further ado, let me start, right? So the agenda. I'm going to be, again, spend a couple minutes, right, to first talk about all these things that are related to events, right? In fact, I'm sure that if you are, brand new to this topic area, or if you have heard of it, or if you're already like, really seasoned, right, so to speak, really like guru. And so if you are kind of finding it too, too like basic, feel free, I don't get offended. I can't see who you are here today. But the thing is too, is that my goal is to try to sort out some of these terms that have become a bit of a confusion, I think, right? And I really have spent a significant amount amount of time trying to sort out all of these terms, including too, actually, reactive systems too, right? That's something that's dear to my heart. I was doing advocacy for that for a while I was at IBM. So, okay, so some basic things, the PubSub, the queuing, and then I'll get into like explaining like why, event streaming can improve your systems, can help you, essentially your goal of your systems. And then also then I'll lead then the conversation, right, this presentation into talking about Apache Pulsar and also highlighting a couple of developer features. So it's not intended to be like a hands-on work, kind of workshop type, as you know, but I wanted to inspire you and get you thinking about it too, of using something like that. And of course too, folks, some of you, I'm guessing that if you have already worked or are already working with events, maybe you're more familiar with Apache Kafka. So I'm going to explain to like why you want to consider Apache Pulsar. So that's kind of about what it is. So very exciting. So let me kind of start the many facets of computing events, right? So first of all, right, like I said, getting into basic, kind of break things down into the atomic kind of meaning of it. So event. Now, as such too, event, right, can be, when it applies to computing, is a different set of requirements and kind of things that we need to think about. But in generically, right, if we think of events, it is essentially talk about, I look up the dictionary, right, based on dictionary, right, that's kind of more a standard definition, right, everybody knows, is basically something that just occur, an occurrence, right, and so to speak. It can be music event, right, you go to a concert. It can be sporting event, and of course the World Cup, soccer, football, right? In many parts of the world, except for America, we call it soccer. So that's about to begin, right? World Cup, that's an event, a big event, in fact. And then of course too, even life events, right? The birth of your baby, right? Birth of your child and all of these things, right? Life cycle, all of these, they are events. So as you can see, events are very much, kind of intertwined into our everyday life. Now, the thing is, when it kind of gets into computing, we gets into some specific of handling events, and it's not the easiest thing, so to speak, right? If you think of events, right, they are kind of all happening. Things are happening without any kind of predetermined, not structured, so to speak, right? Things can be happening randomly or spontaneously. All of these are events. And so now the thing is too, is that we are all, programmers here. I mean, presumably, right? Or developers, or you're interested to enthusiasts, right? About technical stuff. So I looked up too, right? And further down, it's basically, we bring in the theory of relativity. So an event is essentially the fundamental entity, right? This entity is an observed, physical reality. This physical reality is basically represented by 4 dimensions. And the dimension that we're most familiar with as a mathematician, and I was a math and computer major. So if you're math inclined, then it brings in the space, which is XYZ, the 3-dimensional XYZ coordinates, right? So that's an event. But the interesting thing about computing events is that it brings in a 4th dimension, which is, basically is the space and time continuum, right? It is basically on the space dimension to it. So the time dimension. So think of it, space-time continuum is a single event. And that's what we are kind of talking about, right? Computing events, right? And so to me, I think it's exciting. I think it's just so much stuff, and it should be natural. So therefore, the computing world too, if you think about it, we start with something kind of more, so to speak, we simplify things, right? We make it kind of more like synchronous type of programming. Things are like, you issue a command, the command goes, and then you take time, you have to wait for it, and command gets processed, you come back with a response. But no, for event style, we are kind of doing things more natural, to more intuitive to how we work, as human beings, as how, we interact with one another. Everything can be happening at any time. It can have many events happening all asynchronously. So that's the goal. That's computing events. Now, let's kind of take a look to the alphabet soup, I call it, of event computing. What it kind of boils down to, as you can see, I kind of play a little animation here, is data. So data is in fact at the core of all of these event things that we're talking about. But you're saying that, well, hey, isn't it what it is about? Computing too. Yeah, we have algorithms and everything. But essentially, the data is the thing. It captures some information, right? That information that changes its state over time and kind of like that. So if you kind of look into it, right, I call it, different terms and how, computer scientists and people like ourselves, we have kind of called them. You see it, event sourcing, right? Event-driven architecture, event processing, event streaming, event messaging. So that's the theme. I'm talking about event messaging, streaming, and kind of processing, that kind of concepts for today's talk. But if you kind of look at it, right, there's event sourcing. Now, the thing is too, is that event sourcing is also closely related to what we do, in fact, in a true kind of event-driven type of environment. Event sourcing is how we should actually be capturing all of the data. So instead of, let's say, right, and again, if we go back to a more traditional way, is that we have database, and basically we defined it, kind of your structure of your data. And then if it changes state, right, we keep updating. We have a field that keeps track of the state of the data for that particular event, let's say, right, or some entity. And then, but the thing with that kind of way of doing things is that it will be hard to go back in time and see how the data changes over time, right? So that's why too, in a true kind of event kind of system too, is that there's this new terminology, not too new, but newer, right? Newer than the traditional data store kind of way of one table, kind of keeping track of the state at only one particular, or like at the most recent point in time. Basically, event sourcing is that, when event happens, an event is immutable. You cannot go back in time. Think of the fact that, your baby is born. The baby is there. You can't go back in time and say it doesn't happen, right? So basically, you have events, and then it's immutable event. Every time something happens, you cannot go back to history and say and wipe it out. Well, kind of, if you kind of do computer, of course, you can say you wipe it out, but technically speaking, right, it's immutable. You cannot wipe it out. And basically, we keep track of the state of that entity at that point in time. So that's event sourcing. So as you can see, yes, it can have tons of information that we're keeping track of. But the nice thing about this kind of approach is that means we can track, the change of state of that entity as it progresses through time. So that's event sourcing. But I just want to bring that up. I think it's such a neat concept, right? And it needs to be kind of done in most systems, in my opinion. Although, how to do it is another kind of, more, I suppose is a bit more complicated, right? Than if we kind of more used to the database that we're used to, the relational database, object database, graph database, all of these things, right? So anyway, so that's what it is, event sourcing. And then there's event-driven architecture. I mean, as such, it's a bit more abstract. It's the architecture we're taken upon some systems that is kind of essentially driven by events, but basically the change of state of the data, in space and time for your particular system. Anyway, then now we get into event processing, event streaming, event messaging, right? But before we get to that, let me kind of also look into here too. I highlighted, right, some of these, well, one actually event storming. I just want to bring this up. That's another thing. This actually event storming isn't so much about, kind of like actual, like technical, how do you implement something? It's not like mechanics of implementing something. It's really about when you're kind of coming together, you need to kind of come up with idea, right? Ideation of a system. What are you going to do? You need to define the requirements. What are you trying to do, right? That's kind of beyond just the mechanics. It's more like before you start a system, you're supposed to kind of go through, figuring out what is required. So it's kind of very much in line, right? This event storming activity is part of the domain-driven design kind of approach that microservices, development takes on these days. So that's event storming. But again, my talk isn't focused on that, but I wanted to kind of bring that up and clarify the terms here. So that's event storming. You can have a group of folks, in your company, you bring in subject matter expert, you're designing a payment system, you bring in accounting people, you bring in finance people, you bring in the credit card, payables, account payables, all of these people together, including your technical people, you try to come up with requirement, understanding what it is, before you actually start coding. So that's event storming. Now, let's get more into these highlighted ones like microservices. We hear about it all the time. It can be stateless or it can be stateful. I won't go into all the details. I actually have another talk too, is about stateful microservices when I was back at IBM and using profile too. And so that's another topic. But we know that microservices too, in effect, you don't have to take on necessarily an event-driven approach, but it's highly recommended. Why? Because microservice is supposed to be smaller, very efficient, and it encapsulates all of the services that it needs. So it has its own data source, right, that's attached to it, all of these things, or kind of not quite attached to it. When we talk about microservices, especially in the cloud, then basically it's about stateless, right, and it's supposed to be. But anyway, that's another can of worms, so to speak, right? Another kind of set of complexity. I won't get into it, but if you use an event-driven approach, it's actually pretty natural that you should use it too, especially in messaging. How do you communicate different components, with each other, right? So that's that. Now let's get into serverless application. That also is kind of an area very exciting, serverless, right? And serverless as such isn't truly serverless, but it's more like you separate out the application and the infrastructure. So then, the serverless side is basically, as application, I don't need to actually worry so much about the infrastructure, not worry so much about the server. And I let the infrastructure takes care of the infrastructure. I'm an application, I should be able to run on top of anything that's, already supported by the architecture. But that's the goal. But with that kind of an approach, right, doing serverless stuff, is essentially too, using an event-driven approach also is becoming very natural to it, because very often these days is the infrastructure is the cloud, right? A lot of things they are separate systems. So the best to do is basically in a system of having so many different components, doing it in a decoupled fashion, which is supported by event-driven style or programming. That's very natural. So, okay, so that's that. Let's kind of get into my favorite, the highlighted one here, reactive systems. So reactive systems as such, right? If you're familiar with it, it's basically, to me, it's becoming a bit more of a higher level abstract, that deals with what a system should be, right? So it's defined, basically by the reactive manifesto. The four core kind of principles of any reactive systems have to be responsive, have to be very elastic, right? And also very resilient, and also message-driven. So as such, it means it takes on, the message-driven aspect is essentially taking on this event-driven approach, because it promises, guarantees more effective kind of communication. There's actually no wait time if you're communicating different microservices in your system. You have everything kind of all decoupled and you send the messages. You don't wait around until the messages comes back. You do something else while things are being processed, right? All of these approach, right? As such, reactive doesn't tell you exactly how to do it. It doesn't tell you, the mechanics. So that's why it's left up to a lot of vendors kind of define things in their way, but still they kind of secretly, right? They are actually using the event-driven approach. So it's all of these things in here. They are applied for enabling reactive systems to happen. So at least this is how I define it, right? Reactive systems are kind of taking on this event-driven approach very naturally in that sense. So, okay, so let me kind of get on to the next thing. Event streaming and processing, right, is today's talk, or how do I name it? Event streaming and messaging. So they kind of all together, kind of the same, they're slightly different, right? Okay, so let's take a look. Again, event is referring to each data point in a system, right? If you can think of time and space, that point. And the stream is basically referring to an ongoing delivery of those events. So you can have streams kind of coming, the data changes state, you can use a straight line. Their data kind of travels through time, kind of like that. It's the stream that is referring to an ongoing, many events can be happening, kind of like that. And so basically a series of events then can be referred to as streaming data or data streams, right? So I know it is very abstract in a sense. If you think about it, we're representing it using like lines. They may not be straight, but some kind of lines that kind of connected. But in reality, like I said, with event sourcing, where each event that happens is immutable by itself, kind of like that. And so the events can you can source it. So you kind of have the same entity being tracked, over time. So anyway, but going back to this, right, streaming data, I wanted to clarify a little bit. So Apache Pulsar, right, it isn't really for doing like streaming audio, like these days we're talking about, let's watch, streaming a movie or something. Now that involves audio and visual kind of streaming. Now it is about streaming. It's also like deal with events, the data, each, pixel you see on the screen, right? They are they're all represented by some data. But the thing is that with that audio and visual aspect of it, it involves, some synchronous processing when these data are being rendered to their respective media. Let's say you're playing music, playing movie, right? So it's not like we can use Apache Pulsar to do it, but the idea is that, it's the same. It's still streaming, but today with Apache Pulsar, we're talking more about the data, pure data aspect. So. Okay, so now let me kind of take a look, let's take a look into complex event processing. So as such, right, this particular definition, actually, if you're working with Apache Kafka, or you're familiar with the Confluent company that has the managed cloud, right, Confluent system, they actually have this in there. And I thought it makes a lot of sense to also talk about it. System kind of stream processing, right? When you get to this terminology, talking something event processing, complex, right? Complex implies something more complicated. So essentially, too, this means, it's a more like a set of techniques, right? Not just for capturing the changes of these streams of data, but it also involves analyzing these streams of data. And the purpose is to try to identify opportunities or threats, right, in real time. And that's the goal. Now, the real time is the key, right, of all of these event-driven kind of things that we're talking about. And that's why we want to do it, because it promises more real-time kind of approach to solving problem, right? So let's say, right, complex event processing can actually, if you cite an example, it could be fraud detection system. I'm sure that, we all have bank accounts or some form of accounts to manage our money, right? Our income, right? So all of these are kind of basically in the bank. They need, all companies now that are financial will have to have systems that are there to detect fraud, right? Or any kind of strange kind of changes in the data, maybe like, it sees that, okay, let's say I'm based in Chicago. All of a sudden it says, okay, your account got debited like $2,000 and it's being done in somewhere in India or something, right? So that kind of like, if you have a good fraud detection system, it might kind of immediately notify you and say, well, something is wrong, but basically the point is that you have an event-driven system behind the scenes monitoring the data. And then if anything changes, it will be notifying someone, right? So that's kind of complex event processing. You capture the data, you have to analyze it and all of these things. So that's just one example. You can be doing shopping, right? There are recommendation engine, machine learning, AI, kind of application too, right? So many different things. In fact, the possibilities are limitless, right? You can think of anything creatively to solve today's problem using this kind of a complex event processing approach. Now, let's kind of take a look then into messaging. So messaging too, to me, is a bit more of a drier, so to speak, meaning that, it deals more with kind of some fundamentals. We're dealing with messaging that are, involves the sending of messages, right? It gets into the mechanics. So now as such, there are also two terms we describe: event-driven messaging and then message-driven messaging. There's kind of slight differences too I want to bring up in here. And the definition as such came from Lightbend, right? The company that's where Dr. Martin Odersky, the inventor of Scala, is working at, and also where the reactive library Akka is also came out of, right? So anyway, I like that definition. It says that event-driven is essentially there involves, sender and receiver, right? Any kind of messaging system involve sending and the receiving part. So the sender will emit the messages, meaning it sends it or produces the messages. And then it's up to those who are interested in the messages to subscribe to it. And it's not like, the sender will have to worry about the address of who do I send the messages to. It's more like, I'm just gonna like shoot out messages, and whoever is interested, they have to subscribe. And of course, there are different mechanisms, which I'll talk about shortly, but that's event-driven. Now, there's also message-driven. So the definition is that it always like involves only two, sender and receiver. And the difference between this and event-driven, the strict sense, is that sender and receiver will have to know each other's address. So then when I send the messages, I know where the messages is going to go to, right? That type of stuff. So that's kind of a bit of a subtle differences between the two. Now, the thing is too, event-driven approach, events, all of these things are not completely new, as we all know, right? And in fact, I wanted to point out too, with ACA system, right? If you're familiar with ACA, the reactive library, it makes use of an actor model. So an actor model, again, is about, the mailbox kind of messaging between sender and receiver, two entities. Well, so that's not all new, right? It is already like back in the days, there are already telecommunications. In fact, they're already doing a lot of asynchronous event kind of driven approach. Now, in today's world, it's kind of bringing it up again because the hardware is more ready for more sophisticated libraries, software libraries to be built, like hardware virtualization, containers, all of these things. So that's why too is making the event thing kind of come alive even more, so to speak, right? Okay. So now the thing is, event-driven approach, event kind of style of programming isn't for everything. You have to make sure that you use the right tool for the right job. But I wanted to kind of point out too, the more, I guarantee most of us are probably more familiar with, so to speak, like batch processing. This involves essentially changes of data that comes in. We don't process them all at once. We batch it up, where we gather them, and then then maybe at the end of the day, for example, like an employee system in a big company, right? And all of these employees, like you and I, right? We moved, so we update our address. So the address, all of these, whatever changes, gets gathered. At the end of the day, it will be processed as batch, on the system. When the system is more ready to process things, those are not urgent things. So that's the idea. Batch processing in general, you're processing something that are not quite real time, and they can be done, in batch, so to speak, right? And doesn't take as much like network, to kind of go back and forth to, and less of a, definitely not a real time type of approach. So that's that. And now then let's take a look into some of the mechanism, right? The semantics. So when we talk about event driven, very much a lot of times we're streaming, we bring in the PubSub kind of architectural approach, right? It is an architectural approach, and as such, right, it involves essentially the publisher and the subscriber. That's why it's called PubSub, or it's called producer, consumer, right? Kind of approach. Producer or publisher, it sends the data, and it's up to the consumer and the subscriber to subscribe to the messages. And the thing is, very often is that it involves a middleman, right? A middle agent, so to speak. It's the broker, right? So if you're familiar with Kafka, we have Kafka broker. Pulsar also uses the broker to kind of mediate and kind of helps to deliver the messages, receives them and deliver them. There are much more work that a broker does, right? So that's the idea. It's a PubSub. It enables streaming one-to-many, and also can be in high volume as well. Now, the next thing is the next terminology for semantics will be message queuing. So as we all know, queuing too as such, right? And doesn't guarantee order, but messages when they're ready to send. So the sender will send the messages, and basically messages will get queued up, right? It gets queued, but the idea is that it's being consumed by one single consumer. Very often too, it's being used, in service-to-service communication, in serverless application, in microservices kind of architecture too. The idea is that you want to decouple, right, the heavyweight processing, right? So as such, even message queuing and PubSub both are basically very much a decoupled kind of architecture, loosely coupled architecture. So your sender will send the messages, and it's up to the receiver side to receive it at different times, to very asynchronous in nature. So it really helps with scalability, right? High volumes of traffic kind of thing. So these are kind of the two semantics. And now let me kind of quickly kind of go over like why event streaming, right? So I think I already said enough that this becomes self-explanatory. First of all, we need systems. We want to have data being able to, process. You want to be able to get the data and being able to operate on it accordingly, right? In real time. So real time is the first thing. In today's time, we need data, information to be in real time. So real time is one aspect. Another thing is that the building data pipelines too, especially for machine learning, artificial intelligence. That's why too, these are really prime candidates to be using event streaming approach, because as such, right, if you are familiar with AI and machine learning, we're constantly updating the data model. based on the data that comes in, we're learning it and then refining your data model. As you refine it, updating it, you need to redeploy it back into the system. So in order to be able to do this fast cycle without even touching the hard disk, that's not very easy if you use it the traditional way. But using an event streaming library, such as Pulsar, right, it's actually the way to go. And then another thing, of course, too, is about scalability. I talk about, we're ingesting a lot of data. And basically, too, we want this to be very scalable. So event streaming, again, if you look into PubSub message queuing, these, especially PubSub scenario, the publisher doesn't have to worry about the address of the receiver. It actually becomes a very fast type of mechanism. If you think of, I need to send messages to many consumers, right, 10,000, 100,000. If I have to remember everybody's address, I have to spend a lot of time to deal with it. But guess what? The broker will take care of things because I'm going to publish my messages to a broker, to a topic, so to speak, of how to route it. The broker will take care of delivering for me when I'm ready to deliver the messages. So that's really helps with scalability. Okay, so this is just a quick summary of what I just said, right? It's basically we want to make decisions on data in real time and ingest them in high frequency, right? And also respond back with very low latency. So that's the goal. And this one too, I wanted to point out, right? Streaming versus not streaming. If you look kind of below, not streaming, this is kind of a lot of approach that's essentially taken by ETL, older extract, transform, loading kind of process, right? And basically you ingest the data, some amount of data comes in, then you have to persist the data, write it to some kind of data store, database, all of these things. So every time you do this, guess what? There's disk IO involved, right? So if you, any kind of IO input, output kind of processing, it takes time, even if it means nanosecond, it would take time if you're dealing with 1 million records, for example, right? So you need to persist them and select them and process them and persist them again, back and forth. Naturally, it will take more time. However, using a true event streaming, a streaming library, basically you ingest the data and you process the data as they come in memory. So in that case, guess what? Obviously, everything's being done in memory is faster. And then what to do, right? Like you're building data pipeline and you transform the data, immediately everything is done in memory and you output it to a sink, right? That's what it's called. And then you use some connector to connect to different kinds of sync. So think of this fact, right? By itself, this mechanism is already much faster than the older non-streaming way, right? And you can do things essentially in memory. Now, then let me introduce to you Apache Pulsar. What is Apache Pulsar? It's an open source library, is an Apache project, and started off created by Yahoo back in 2010 in that early time frame when they are already dealing with a lot of Yahoo messages in the cloud. They're early cloud adopters, but they realized at that point, there were no true distributed messaging systems that can handle the load and in the cloud. So then they started to develop their own. It's called Pulsar. They named it Pulsar. They donated it to ASF, the Apache Foundation, in 2016. And very quickly, 2018 became a top level project. And in today, actually, it has become one of the top 5 projects of Apache Software Foundation. So it signals like how important this library is, right? So what makes it very important? It's because it's very much a cloud native aware type of design, right? So it kind of is cluster based and also handles your data. Is called multi-tenancy. It helps you to kind of not just messages, but it already kind of enables you to organize the data accordingly. Is this using this multi-tenancy kind of approach? Also, too, it separates out the compute and the storage, meaning that, I'm the message broker. I only worry about processing all of these messages, but what to do with the messages after you deliver it? And that's where comes in, right? Kafka is actually doesn't separate them out, but I believe Kafka is trying to do that now, but it's not naturally being designed that way. Whereas Pulsar is being designed, with that in mind. So instead of Pulsar worrying about this large chunk of, kind of incoming log messages, it actually said, okay, let me delegate to somebody else. And they picked Apache Bookkeeper, another Apache open source library that specializes in processing huge amounts of data, fast read, fast write, all of these things. So So that's what it is. And also too, when you kind of work with the Pulsar broker too, is that, the broker itself is a serverless process, is JVM, Java. But the thing is, when you write your producer client, consumer client, your subscriber, all of these, you can write it in not just in Java. If you're not familiar with Java, you are more about a, .NET, C#, it's supported too. C++ is supported, Python, Go, and a lot of other community supported languages such as Scala, for example, that's one of them. Rust is also being supported. And that's just a couple of examples. You can kind of look up documentation to see what else is being supported. And also the message delivery part too is guaranteed. So if your network goes away, because you have already produced messages to the broker will take care and guarantee the messages gets delivered for you. So that's also very important. And another part of Pulsar is the serverless functions framework. So basically you have data ingested, you need to transform the data while it is kind of traveling through the pipeline. You can actually use the Pulsar function framework. It's a very lightweight approach, kind of like AWS Lambda, kind of same kind of concepts thing. So you can do that too. It operates very well in a cluster. And also there's this tiered storage offloads too. So very often, right, we have all these tons of data, it becomes cold, you're not doing anything to it, and they are ready to be archived, so to speak. So Pulsar has this infrastructure aware type of mechanism. It will move your code data to offline storages, such as S3, right? It's about the S3 bucket, and it supports all of these things too. So then you can free up room in the hot storage to take care of more urgent kind of things that are happening. So. All right, so this is just a quick thing. You kind of just wanted to kind of prove it to you, the amount of GitHub stars, GitHub contributors, and it's kind of over above that of Kafka contributors too. And who else is using Pulsar? So as you can see here, there's Yahoo, right, Comcast, and they are using it too. Splunk, Verizon, a couple also major companies, information services company in China as well. And Pulsar is very different. Now over here too, I already kind of talked about you have producer and consumer, broker, and the bookkeeper. And also it uses Zookeeper for managing the cluster metadata, handles coordination of tasks between all of these Pulsar clusters too. So it's kind of well designed. It's kind of a multi-node type of tiered architecture. Okay, so this, I won't kind of get into all the details in here because I'm kind of running a little, kind of low in time, but I wanted to respect that. So just want to kind of summarize, right? It is a unified solution for PubSub, for message queuing, and also for streaming, message mediation, and enrichment out of the box, right? Let's say I'm already using Kafka, I'm using JMS, right? I'm using RabbitMQ, all of these in here, and even other types of environment that you are using, any other things, right? That are other frameworks too. Basically, Pulsar is so friendly, right? So kind of accommodating. It comes in, you kind of like bolt it on because it's data streaming, PubSub type of thing. You can kind of quickly kind of plug it in without changing what you already have. Okay, so these are differentiator. Separation between compute and storage, I talk about that. There's also a feature called geo-replication. So basically you have data centers scattered everywhere that are handling all of the data. It has features that enable you to do replication between different data centers very efficiently, also while they're active. And also you can select to selective kind of replication as well, all kind of built in and configurable. There's multi-tenancy. So I was just explaining that basically all the data coming in is already kind of managed by different tenants, right? And also the flexible message processing. There are 4 modes of subscription. It can be exclusive, which turns it into a message queue one-to-one, limiting only one consumer. And you can have failovers, kind of consuming subscription that allows, that are backup kind of consumers. There also shared subscription with many consumers. And then there's also key share, which is like if you want to preserve the order of the messages. Okay, so I think I may be like a little bit out of time, but here too, like I said, right, I'm just going over a couple features, but I wanted to quickly tell you about DataStax. We have Astra Streaming, is already hosted kind of option, or you can host your own and you use our Luna Streaming, or you can use completely open source. We also help you out too. Okay, so this is that, and a demo, I won't have time, but I wanted to share with you a couple things before I go. Over here. Right, so you kind of all of these, take a look at this. I wanted to point out that, again, DataStax, we have Astra database. quickly to kind of show it to you too. This one, right? Estra database, you can sign up and we'll get it for free too, basically. Again, I won't have time to do the demo in here, but I wanted to show it to you. Sign up for it. You get $25 credit every month. So continuously, you get $300 per year, US dollar, and you can try things out. You can actually try out Cassandra, Create Database, or Create Stream, Pulsar Stream too. So that's something I wanted to kind of share with you. It's over here, estra.datastax.com, all of these. And then also, if you want to have extra credit, this is the link to have, and that's the code you can use to open source 200. And then also 5 minutes about Pulsar on our DataStax developer channel. Also, I have a Twitch stream. So every Wednesday, but actually today I'm going to do one in just 2 hours or so. So if you follow me, you'll get subscription or notification too. So I have this, my Twitch handle. I go more in depth and you can also interact with me more. And we also have DataStax at Awesome Master for you to kind of like look at code samples and learn more about things for free. And I think then that's all, right? Okay. And how did that happen? That's kind of weird. Yeah, okay, all right. I don't know how it happened. Okay, sorry. And here, over here, Pulsar community information too. This is the different links. You can join the Pulsar, Apache Pulsar project, sign up for the Slack too. And with that, you know, I'm right on the ending mark, and this is how you can get a hold of me, right? These are, follow me on Twitter, on LinkedIn, and also I have my Discord channel. And again, I also have my Twitch and also have my blog post too. But if you follow me, we'll continue the conversation. With that, thank you very much. And let me see if there are questions. And I think there are chat. Oh, somebody, okay. Somebody asked me something. Okay, I don't see a question. So with that, I think please follow me and ask me questions on my Discord channel. Oh, somebody did ask something. I see something now. Okay. Oh, George, thank you. Thank you very much. I hope it is helpful for you. Thank you. Yeah. So please, you know, connect with me on my Discord. We can have more, you know, questions over there. You can share with me your projects, questions, everything. So I love to learn from you as well. So thank you very much. Yeah. And I guess I will wait in here for a couple minutes, I think, right? And if there are more questions, feel free to send me here. I'll stay here for a couple minutes and yeah. So I don't want to take time from you too. Maybe there are more presentations afterwards. No? Oh, Maria, you're welcome. Thank you. Thank you for spending your time and hearing me talk. So thank you very much, Maria. And I hope to visit Greece. I think I have a chance to visit Greece, in fact, next year. I think with the Vox Days, if you're familiar with Vox Days, right, there's also the conference that have invited me to speak there. Because I spoke at Vox Days Thessaloniki in June, I had a great time. So I think they're, you know, kind of accepted me to speak at Athens next year. So yeah, I hope to meet you, some of you there, if you're going there. So, okay. Oh, when? Yes, Maria. I think the Vox Days, what they told me is should be in June, May or June. So if you're familiar, right? There's let me kind of quickly say Vox Days, right? Athens. Okay. Okay, so I answered there and kind of provided you Vox Days Athens. So if you want to search for that and then follow that, and then they would publish the date when they are ready. So, or if you follow them, I think on Twitter too, then you also, they will pop up, right? The tweets will show up too. They usually announce it there too. So, yeah. So, yeah. And I believe Thessaloniki, maybe they're also doing another conference too. And I was there back in June or May, I can't remember. June. Yeah. Anyway, it was in the spring before the summer. I had a great time. Yeah. I really, really enjoy it. So yeah. So thank you. So yeah. So, okay. And yeah, I think, let me see my, okay. All right, cool. Yeah. Okay. All right. I have to close my share. Okay. I think I did, right? Yeah. Okay. All right, then I think I'm all good. Yeah, right now, right? It's not already done, right? Okay. I wanted to make sure that I'm following instruction, but thank you very much. And I will log off now. Okay. Thanks. Bye.